Hi, my name is Andre Cadadia. I'm a consultant with Lion Environmental, and today my presentation is about vapor intrusion. There are two other vapor intrusion presentations going on today, but I'm going to focus on why vapor intrusion is considered a hazard and my experience as an environmental regulator for the state of Arizona. Vapor intrusion is defined as the migration of volatile compounds into occupied spaces from underlying contaminated soils and groundwater. The US EPA has its definition of vapor intrusion, and Nicole in 2004 said that vapor intrusion was to be addressed through modeling and risk assessment. The sources of volatile organic compounds come from two places. From petroleum hydrocarbons, we get the BTEXs, benzene, ethylbenzene, toluene, xylene, and we get chlorinated hydrocarbons like PCE, TCE, TCA. We also have inorganic sources for vapor intrusion, those being radon and mercury. While I'm not going to discuss them today, it should be noted that radon was the first vapor intrusive uh, element that was studied and understanding. I think it's important to say that any volatile compound can have a vapor intrusive issue associated with it. What are the risks of vapor intrusion? Why do we look at them at all, considering they're such low levels? Well, when we study them, we find that we need to understand that the toxicity of the compounds, that is, a chemical's ability to cause adverse effects, does it cause harm? And then we have to look at what are the concentrations that we have, the exposures, and what are the routes in which we can be exposed to them. So we always say, what are the exposures? What are the hazards? And what are the risks? These are the things that we have to answer for vapor intrusion. And the data comes from animal studies primarily, or almost exclusively. And on your lower left, this is what a rat study looks like. It's hard to get photographs of these. And this is rats that are put in a device that are forcing them to breathe a concentration of gases over a long period of time. They are then removed and analyzed to see what ill effects that this exposure has caused. Now, the petroleum hydrocarbons, or the BTEXs, are just one example, and their information that we find on this can really come in two different places. It's compiled in various governments, the government of Canada, the Netherlands, and the European Commission all compile data regarding exposure to different chemicals. But it can also be broken out into two different places, into workplace exposures. That's where people get exposed to these chemicals in 8-hour days over a 5-day work week. And then the long-term exposures that are associated with people that are habitating places where those exposures can come about. Now, for my project that I'm going to be discussing, we really had concerns regarding chlorinated organics, and specifically PCE. This was a regularly used degreasing agent in industry, but very heavily used with dry cleaning of clothes. And its hazards associated as a suspected carcinogen have to do with cancers, cervical cancer, non-Hodgkin lymphoma, urinary and bladder cancer, leukemia. That's the compound that was most concerned that I'm going to be speaking about. And when we do the studies on risk assessment, we're always looking at the relationship between dose and response. We're looking at those for carcinogens and non-carcinogens and over time. And this is an example of a typical dose response curve. This is for a non-carcinogenic material. We have a threshold dose, the point at which we see responses initially happening, and then the point in which a lethal dose, or LD50, which half the sample population dies from the exposure. Now, for carcinogens, it's a little more complex. We look at the dose and response over time, but we're also looking at what we do is the slope of the steepness of the slope of the curve to determine as to how toxic or carcinogenic that material is. But when we talk about exposures in humans, we're always talking about who are the most vulnerable, who are the most sensitive in the population to exposures to toxins. And it's children. But why is it children? And we can see from a simple dose response equation, if we're looking at the milligrams of dose divided by the kilogram of body weight over time, if the smaller the kilogram of body weight, which is the denominator, the smaller that number, the more impact that that the dose has on the individual, on the subject. So this is why children are considered the most sensitive receptors. And what drives us in the environmental industry more than anything is epidemiological studies of communities that are exposed to environmental contaminants and exhibit elevated levels of certain types of cancers. A great place to see this in cinema is the story of Erin Brockovich, which was starred Julia Roberts, which studied a cancer cluster in California. Now, what we're concerned with vapor intrusion is, do we have a source? It means a source that we have a contaminant. And do we have a pathway that connects that source with human receptors? And in the case of the project that I'm going to discuss with you, we had both. We had a contaminant that we knew had hazards, and we knew we could identify pathways where there were going to be exposures to the community. Why were we doing these studies? Well, we knew that we had groundwater contamination. We knew that there were releases, and we were compiling a remedial investigation and feasibility study that was necessary to understand the full extent of the problem and how to solve it. We would take this information and use it to compare it to various tables and study information or exposure levels that have been compiled as part of the Superfund program. Now, the Superfund was created in the U.S. This is why there's so much data associated with the U.S. because it started in 1980, and it was then amended and readjusted again, or reauthorized and adjusted in 1986. So since the inception of Superfund, there has been this collection of information and data that's been used as part of risk assessments. It was first compiled completely in 1988, but this is why there's so much data on the U.S. side, because it's been going on for so long. As an environmental regulator, what we were trying to do was we were trying to weigh the information that we had in terms of potential exposures, find out as much as we can, and then use that to base an assessment on what was the risk to the communities that we had that are concerned. So to be on the point, to get there specifically, let's look at the Arizona experience. Now, Arizona's Superfund program is called WARF, which stands for the Water Quality Assurance Revolving Fund. That's the state program, not the federal program. The state program is funded through mandated legislative monies. It's specifically set up in the water regulations because water is pretty key and important in a state that has mostly deserts. And it's in part of that program, we had the responsibility was to look at any potential hazards and express them to the community itself. And I'll explain that in a moment. Now, this is a representation of the current understanding, not at the time of the study I'm going to talk about, but the current understanding of the contaminated plumes in Phoenix, Arizona. The brown are the state run projects, the state plumes, the state groundwater contamination. The green are the federal projects. There's 3 operating units in the federal project, and there's multiple sites in the state projects. Now, the reason for the shapes of these is you first have to understand the geology of Phoenix. Phoenix sits in the bottom of a valley. That's a Salt River Valley. You can see the representation of the river on this map. There are mountain ranges to the south, mountain ranges to the north, and to the east. The river runs out of the range from the east and through the center of the valley. The reason the plumes are positioned in this way, and our understanding, is that they're really following basically an archaic riverbed, or the basin that runs through the center of the valley, and all the plumes collect and run here. And our project that we're doing is the East Central Phoenix, which is up in the top sort of right hand side. This was the understanding of what we knew of the plume when we started the project. This is 32nd Street and Indian School Road. We knew that we had a source area which was a defunct dry cleaner, a no longer operating dry cleaner, and we also knew that we had another potential source area to the north, that little blob, which was another dry cleaner. And we knew that the plume ran through the center of the, it's running through the center of the site, ran under both single and multi-family houses. This was a very working class community, and there are shopping centers and so forth here. The second site that we were concerned about was 48th Street and Indian School. And in this site was a far more affluent community. And we knew the plume, which also originated from a dry cleaner, ran under the Arcadia High School campus. That circular building is part of that, of Arcadia High School. The two notable graduates of that school, and there are actually quite a few, but the ones most recognizable are Alice Cooper and Steven Spielberg. This, as I said, was an affluent community which offered its own sort of issues. So in order for us to proceed, we needed to do something. We had to get the governor of the state of Arizona to allow us to proceed with setting up guidance. We had, because vapor intrusion is not regulated on a federal level, it's only regulated on the state levels, we had to get their approval to proceed, to go forward. What we did was we put this is the document we actually put together for the governor. So it was simple for the politicians. And that is, we put together what vapor intrusion was, why it was important, the other states that had some kind of guidance, the Arizona vapor issues that were going on at the federal sites, as well as what our site was in East Central Phoenix, and our approach. And we also put in a section about understanding that there was a media coverage of these issues as well, that we had to contend with, that they should be aware of. The governor approved us to proceed, and that ended up meaning that we had to put together a flow chart on what we were trying to do. And this is our flow chart. It was the decision chart on what we were going to do and the screening levels that we had to set up. Now, we had to do this in 2 times of the year because vapor intrusion is an issue that has to be presented, the scene, from different times that the people's homes are occupied. Meaning in Arizona in the summer, we have very hot temperatures, high 30s, low 40s at times. That means people collect inside and run their air conditioning units, which tend to depressurize the homes that potentially can bring in vapors. While in the winter, all the doors and windows are open to appreciate the good weather. Now, this is the opposite as in Poland. So we knew our study had to both be one in summer and one in winter. Now we set up our action levels. We knew that in soil vapor that we were going to be concerned with vapor that was at concentrations of 313 ppb per cubic meter. We also, that was based on an excessive cancer risk level of 10 to the minus 6, or 1 in a million cancers. For an indoor action level, we knew it had to be greater than 9.4 parts per billion. Now this was opposed to Now this was all for PCE, as opposed to the federal site, which was concerned, the contaminant of concern was TCE. We had to put together fact sheets. We had to talk to different agencies. We had to talk to the Community Action Board. We had to create mailers that we had to have approved before we could send them out. We knew we were going to go door to door. We had to contact homeowners associations, schools. There was quite a bit of effort that we had to do. We had to get it approved. We had to make sure our documents were reviewed by the state attorneys general in order to verify that they were within conformance with state's laws. And we had to pick a sampling methodology. So we looked at different ones. Here's examples of some of the ones that are available out there. And what we ended up deciding on for this project was to have a mobile laboratory where we would use a glass syringe and take grab samples from the wells. We did direct push wells, which we would grab a sample from and then run it directly into a gas chromatograph with a electron capture device, or ECD, to detector in order to read the um, uh, chlorinated hydrocarbons. And then we would also use the same method to do inside homes and verify that with Suma canisters as well. And we did them both, as I said, in August and in October to verify the concentrations. We had a very steep project timeline. We started in um, began in mid-May. As I said, we had to do all these approvals for it. We had to also make sure we did some of these in Spanish because we had communities, and some of the people in the communities were not English speakers, so we had some bilingual people from the agency work with us. We mobilized a lot of different peoples. We knocked on 348 homes, 152 residents. We had 119 signed access agreements. We need to have an access agreement in order to allow people inside homes. That was a requirement. We sampled at the end of August, and then we came back in late October to complete the project as well. It was quite an undertaking. We mobilized a lot of the staff, and we did it in a very short order of time. This is 32nd Street. This is what the plume, we ended up realizing what the plume really was based on our sampling requirements. We had two plumes that mingled, emerged together, both from dry cleaners. We had an area of concern is Maggie's Place, which is was a home for battered women with children, which had a basement, which is very uncommon in Phoenix to have basements in homes. And so that was a concern. That was an area that they congregated. We realized that the plume was far more extensive than we originally had thought it was, and we sampled a lot of the homes on the ground level that we thought were at greatest risk. At 48th Street, we did not have as many homes. We did sample a few of them, but we sampled extensively in the high school, considering that was we felt was the greatest risk. We also came to understand that there was also a daycare center which never let us come in and actually sample. We thought that was a great risk. It was right next to our source area. We we did, as I said, mentioned that we had a glass sample syringe was our grab, and then we would take a Suma canisters to verify the grab samples as well. And we ran 24-hour Suma canisters, and we did some verification with smaller 1 liter Suma canisters. We collected 134 indoor air samples, 30 of which were from the high school, and 200 indoor air samples in a total of 5 days. We also had to contend with interferences. There are a lot of things that interfere with vapor intrusive studies. We found plug-in air fresheners our biggest problem. Every single home that had a plug-in air freshener came out above our action level. We had to go back to the homeowner, ask them to unplug the fresheners, wait 24 hours, and then resample those as well. I will not have a plug-in air freshener in my house because of the study that we did here as well. As I said, we confirmed the samples with the 24-hour Suma canisters. We basically found that there were no we had no homes that were exceeding our action levels. We also found that the PCE grab samples that were being done with the glass syringes were slightly biased high, so we made us really very confident that the levels that we were finding in all the studies were actual reading the actual concentrations in the home. So we basically eliminated those issues as vapor intrusive issues that had any ill effects. We were prepared to do mitigation levels, and I'm sure someone in the coming presentations will talk about how to disconnect the source or the exposure by disconnecting the pathways. I hope that everyone has a really enjoyable day and they find that the information that we present here as being very useful in understanding the various environmental issues that are being faced. So again, Thank you very much.